birds will be uh, um, 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 birds can be easily seen. Now, electrical discharge machining has been done, and we are trying to find out the output, like material removal rate, tool wear rate. These are the standard notations, and the circularity, and the experiment have been conducted. Uh, Experiments have been conducted using Taguchi's L16 experiment, and these are the parameters that we set for the uh, uh, for electrical discharge machining: discharge current, pulse on time, duty cycle, flushing pressure, weight percentage of silicon carbide, and mesh size of the uh, 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 that is the particle size used uh, during powder metallurgy. Then output we found out material removal rate, tool wear rate, surface roughness after the machining, then circularity. Okay, these are the now these all these material removal rate higher is the better. If you have more material removal rate, it is better. Tool wear rate, the tool, the copper tool has been used here, and the tool, if you have a tool wear is less, then that is desirable. Surface roughness should be less, and circularity will be maximized. Okay, now we have four types of data. Now this is to be uh, we make it same. It should represent same variation, but we want to make it small number of data so that we can use in the neural network for easy or make the computation easy. Then how to do that? We use that by principal component analysis. Now first you convert all these outputs to signal to noise ratio. Now the signal to noise ratio, for the larger the better and the lower the better signal to noise ratio, these formula are given here. So we convert all the signal to noise ratio. This is the signal to noise ratio for MRR, signal to noise ratio for TWR, signal to noise ratio for surface roughness, signal to noise ratio for circularity. Now the Excel sheet for calculation of signal to noise ratio is given here. These are the calculations that and we find out the maximum and the minimum that we found out. So signal to noise ratio have been calculated. Once find out the signal to noise ratio, you can find out the you can normalize the signal to noise ratio so that all value will be between 0 to 1. So normalization has been done. Normalization has been done. Once you normalize, then you see whether the data has the output response, they have any correlation or not. So the correlation has been found out using this formula. Now it has been observed that tool wear is highly correlated negatively with material removal rate, showing correlation coefficient of minus 0.866. So that increase in TWR causes decrease in MRR. Similarly, surface roughness RA is highly positively correlated with material removal rate, showing correlation coefficient of 0.714. That is increase of MRR causes increase in RA. TWR shows a mild correlation with RA with a correlation coefficient of 0.465. Now we have found out the correlation only to prove that when you find out the principal components, then principal components are uncorrelated components. There is no, you cannot establish correlation among the principal components. It is only the data reduction techniques. It doesn't represent the same data, but it represents the same variation what original data represents, and the same variation will be represented with the principal components explained by the principal components, same variation, or only the number of variables have been reduced, will be reduced, and all the principal components are orthogonal to each other and they do not have any correlation like your original data may have correlation, but the principal components will not have any correlation. So these are the formula that is used for finding out the correlation. Now, for this data, you see the correlation principal component you see here. This has been I have found out by Minitab in software, but you can also find out using MATLAB. In MATLAB, there is a statistical toolbox. You can use the statistical toolbox to find out the correlation. So here, now this is the data, 4 types of data that we have. These are the normalized MRR, normalized tool wear rate, normalized surface roughness, normalized circularity that has been given. Now you go to statistics here, then go to multivariate and go to principal component. Now there are 4 variables. These are the normalized MRR, normalized tool wear rate, normalized surface roughness, and normalized circularity. Then select it. Then type the number of components you want to compute. You may compute 4 components also. And plot the script plot. So when you find out 4 components, so these are the coefficients for the 4 components that you will get. Okay, now suppose I want to reduce it because 4 was making a problem, number of data we had more. So suppose I want to reduce it. So I can make it 3. Instead of 4, we make it 3. Now, you see here, when I used 4 components, the first component used to explain 59.7% of the variation by the first component. Second component was explaining 25.3%, and the third component was explaining 13.4%, and the fourth component was explaining only 1.6% of the variation. So this is the proportion of variation that was explained. And here it is given the cumulative variation explained by component, and it should be 1. So these are the coefficients for different principal components that we have found out. Now, if I make it 3, you see the first component that explains 59.7%. Second component was explaining 25.3%, and third component is explaining 13.4%, and fourth component was explaining 1.6%. So 2%, 1.6%, in respect to 100%, it is very small. So we can neglect that. We can use the 3 components only. So these are the principal components, 3 components, and this is the coefficients that we will use to convert the principal component, to convert to the original data to be converted to the principal components. Now this is the script plot which represents what is the proportion of variation explained by each component. This is the component 1, component 2, component 3, component 4, and it will give you the eigenvalue, because in fact the principal component analysis is an eigenvalue problem, so it shows the eigenvalues. That is not important what we see, but now once you find out these principal components, once you find out or using the principal component analysis, once you find out these coefficients, then multiply these coefficient with the original data, that is the, or use these equations, coefficients multiplied by the data x1, x2, like that. So that will give the principal component 1, similarly principal component 2, principal component 3. So the first one is 0.77436. So for the first principal component PC1, for the first data, 0.627 multiplied by 0.77436 plus 0.576 multiplied by 0.39279 multiplied by 0.39279, then 0.518 multiplied by 0.91768, 0.91768, then 0.083 multiplied by 0.74499795. So first principal component is, for the first data, first principal component 0.77. Similarly for the second principal component and the third principal component, you can find out. Now, so all the components have been found out, principal components. If you see, if you calculate the correlation coefficient among these principal components, then it will be 0. They are uncorrelated components. So there were 4 data: TWR, MRR, RA, and circularity. These have been converted to only 3 principal components. What are the information available with the 4 data? Is same information is available, or same variation is available with these principal components. So that will be useful in the neural network. The number of the computation time that can be reduced. Now, I can give you how can you solve the neural network problem using MATLAB. Now, in the MATLAB, you have toolbox, but I feel comfortable to write a program for that, so that easily you can modify and change and see what you want to do. Now, for doing that, whether you go um, use um, uh, use a toolbox or write a program in MATLAB, all the data must be stored in a file. Okay. Now first I shall give you the input data. Now first let us check the input data. We have divided the data into, we have inputs and the outputs. We have divided data into training data and the testing data. Now this TR input 1 is a file for training input data. Training input data, you see TR input 1 data. All the files have been saved as a CSV file. Now these are the normalized data. I have told you that you have to normalize the data because you need to about the scaling effect. So the input, there are 5 number of inputs. The number of neurons in the input is 5. So how many data we are having? Sorry. TR input data So this is that. So 5 number of inputs, 5 variables are there, and we have 120 data. Now in this file, only the input variables have been written, and from the whatever we got from the experiment, only those input variables we have written. So 5 input data, 5 columns for 5 variables, and 120 data. Now for each row, there is a corresponding output. That is the output. In the training, we need the input output as well. So the output is given TR output 1. So training output for 120 data is given here. Okay. Now, the next is we have to. So this is the training and training data, input data and the output data. Similarly, you have for the testing data. So that is PR input 1. So there is the 5 data, and this is what the 20 data we have given, and the network will, if you give the input, then output it will predict automatically. Of course, for the calculation of the prediction error, output error, we have given the here output or the output testing data also, prediction value, or the testing output data also. Okay, so input and output data set have been generated, found out, and these have been saved as CSV files. Then there is a program written here. First is the clear all. Then you load the TR input data, that is the training input data. Then also load the TR output data. Then take the transpose, because these data are in the column format and the neural network understands on the row format as far as the neural network is concerned. So we have transposed these data. We transpose that is the training input data has been transposed here. Training output data has been transposed, and then this is the training or the what is the input values and the target values, output values. Then you see this is the command given for normalizing the data. Data need not to be, you need not to give the normalization data. Neural MATLAB has its own way of normalization. So here the data is given for the normalization. Then you create the architecture of the neural network, how many input neurons, output neurons, and the number of hidden layers and number of neurons in the hidden layer. So this is what the new FF or the feed-forward network has been given or defined. Now here you see -1, 1, -1, 1. This will appear 5 times. It depends on the number of input variables that we are having. Okay, and all the data is between -1 to +1, because we have normalized the data using this equation. So all are in -1. All the data varies from -1 to +1. So we have 5 data points. Then 7 is the number of neurons at the hidden layer. So if you have you consider 2 hidden layers, then you give 7, 7. So number of neurons in each hidden layer is 7. If you want to have say only 1 hidden layer with 10 number of neurons, then instead of 7 you give 10, right? And the output neuron is 1. Output is 1 only. Then this is a tan sigmoidal function, that is the activation function that we use for input to hidden. Then from the hidden to output, you see you have given pure linear activation function, right? And then train LM, this is for the neural network. You have to define train LM. L defines for the learning parameter, M defines for the momentum parameter. There are a lot of functions. Train LM, similar lot of functions will be available in the toolbox. But since you are using the learning rate and the momentum rate, so that's why you have used the train LM. Then this is for the showing the results for output. So net dot trend parameter dot show 1000. It will show after 1000 iterations what is happening. Then net trend parameter LR, that is the learning rate, 0.07. Then trend parameter dot MC, that is the momentum parameter, we have given 0.5. Then training parameter number of epochs or number of iterations, that is 2000 we have given. We can increase it. Suppose I make it 5000, nothing will happen. Only thing is you have to see where it is converges. Then the then we have given the here the goal, or what is the error that is tolerable, that is 10 to the power minus 3, that is given LE3. Now to initially all the connection weights are randomly generated. So we take a seed value for the random number, and we have given a random seed here. So from that seed the random numbers will be generated. Then net initialize the net, that is for the initialization. Then net, what you have the new neural network feed forward function that you have defined. First you have initialized, then it is you have given the training. After the training, then you will get it to simulate. Then once you simulate, the output will be generated. Then you have normalized previously, then denormalized. So it is denormalized. Then also find out the regression equation, what is the predicted, what is the value, testing value what you have given, training value what you output what I had given, and what is the predicted from the neural network. So between these two you develop some regression model, then find out the and in the prediction also the similar thing. You give inputs or for the testing also give the input, the testing data, then normalize them, then simulate. Then already the neural network is defined, you need not to do anything. You have to simulate or generate the output, then calculate the difference between what is output is generated and what is input given during that training, and as well as the testing for the prediction. So this is the way this program is written, and it is very simple program. Also you can do of course you can solve by using the MATLAB toolbox. NNet toolbox is available. Now solve it, run this program, right? Now you see the regression between the output and the target values during the testing training period. R square value got very good R square value, 0.99 or 99.8% that you got. Now you see the performance, how the error has been changed. Right? Now calculate the or find out the prediction values. You can find out also. That is the during training the prediction value is A. Or the matrix is, sorry. Okay. Then difference, already difference is that during training, what is the output generated by the network or forecasted, predicted by the network, and what is the actual value during that training period. So that difference we have found out. You see the difference is less than 0.01, or difference is very, very small. You can calculate the error also. Error I have not calculated. Error you can calculate. Similarly, for the prediction, the output predicted by the network. This is the output predicted by the network. And we have already you are having here output 1 that will show you what is the output given for the prediction purpose or the testing purpose. Then you can calculate the difference and you know the error you can easily find out. So this is the way the neural network can be done. So apart from the neural network, we have several ways like fuzzy inference system, neurofuzzy system. So many systems are available, or genetic programming, support vector machine. So many prediction tools are available to improve the prediction accuracy, and each is based on some logic, some ideas, some theory. So there is another example what we have used, that is the prediction of quality of the laser drilled holes. Now here laser drilling has been carried out on AISI 316 seeds, having thickness of 0.45 mm. Okay, it was a ND laser, and the specification for the laser that is given here. Offset distance maintained was 3 mm. So this is the schematic diagram for the laser drilling setup. This is the drilling spot and the laser source, then laser beam. This is the assistant gas is one inert gas argon is used to remove the molten material from the hole. Okay. Now here also experiments have been carried out by changing different parameters, the laser parameters, pulse width, current, pulse frequency, and argon pressure of argon gas. Then inputs are 27 experiments have been carried out by changing the variables A, B, C, D, pulse width, current, pulse frequency, gas pressure. Then outputs that we wanted to generate is the circularity at the entry, at the drill. It is a throw hole, so we have something circularity at the entry and the exit. These are two important characteristics, because as the laser goes inside the material, the laser is absorbed by the material, so the power decreases. So at the exit side, we may not have good circularity. Okay, so this is the entry side circularity. This is the circularity at the exit. Then the laser uses a heat source. That's why you will have the heat affected zone near the laser periphery of the hole. So this is the heat affected zone. This is the sputter area. When at the laser enters, the material will be at the beginning. Material will be spread over, or if it is not flushed properly, then the material will come out at the surface and deposited there. That is what we call a sputter area. Then taper, whether a concentric hole you are getting or not, so you can measure by the taper. So 5 outputs have been considered. Then here is a model called ANFIS, Adaptive Neurophagy Inference System. UNFIS, which takes into account the neural network as well as the um, fuzzy inference system. And UNFIS has been used by many researchers for the prediction purpose. Normally, UNFIS has 5 layers, that is the input layer, then fuzzifying layer, and product layer, then normalization layer, and then finally defuzzification and the output. So some 5 layers are there, and there are different mathematical equation used in different layers. I'm not going to the mathematical equations how to do that, but only thing is, if you use UNFIS edit in MATLAB, then it will show you a screen which can give you can help you to solve the UNFIS problem or predict the output using the UNFIS. Simply type at the command window UNFIS edit, ANFISEDIT, UNFIS edit. Now, UNFIS, what it does, like fuzzy inference system will generate the rules. The rules will be generated here automatically. You have to simply give the inputs, then the rules will be generated and it will predict the outputs. Usual, there will be training and testing. So these are the rule editor or the rule generation. Then this is the network inputs, then rules, outputs. So that way we have all the 5 layers have been shown here. Then this is the training data. When we have given the training data, then how it has been output is generated. You see here how you can give for the training and testing and view all these things. And if you use the subclustering, generate FIS, if you give subclustering or grid partition, then it works better. Data you have loaded, here the loading for the data, here you generate the fees. So you have to choose between grid partition and subclustering. Then you give the error tolerance here and train test what you want you do. Okay, so this is for the training data, then this is for the testing data. Then once you use the UNFIS, you have used the training data and the testing data, then the performance you see this is the UNFIS output that we get for the training as well as the testing. And here the root mean square error is used for the measure of whether we are properly anticipating the results or not. So these are the root mean square error, which happen to be very small. So these are this way you can do the training. Of course, time is limited. That's why I have not covered his, which is fuzzy inference system and genetic program. These are and support vector machine. These are really interesting and good prediction tools, which are extensively used for prediction of outputs in manufacturing. I have given only few aspects, that is neural network, that to backpropagation algorithm. I have not covered all the types of neural network, only backpropagation, how to use that, and also how to use the UNFIS model using the MATLAB. So with this, I can stop here, and now it is open for discussion. If you have any question regarding the application of the prediction tools in manufacturing, you can ask me. Not necessarily from what I have discussed today, but you can ask any question, please. Okay. Please share. Hello.
Participants,
Ah,
Hello. Participants, if you have any query, you can put it on the chat box or you can unmute yourself and directly ask. Sir, participants, they actually belong to various disciplines of engineering, not only manufacturing, there are electronics and other discipline participants as well. So they can go ahead and
okay,
ask questions if they have any.
okay, okay, fine.
Sir, as no queries coming from their side, I think we can conclude here.
Okay, fine, no issue.
Thank you, sir. Thank you very much for accepting the invitation. Uh, no program of ours is complete without your association, sir. So thank you very much again for
Thank
accepting the invitation within a short period of time. And this session, personally, I felt it was a very informative and productive one. So I'm sure the participants are going to get some benefit out of it. So thank you, sir. Thank you very much.
Okay, thank you very much. Okay, fine.
Thank you, sir. Hello, sir. Hello.
Hello.
Sir, one participant has a query. If you can kindly address.
Okay,
He's
okay,
asking,
please.
can you specify the toolbox using Skylab as it is open source?
Skylab I have not explored. I'm mostly using the MATLAB, so I cannot answer this. Skylab I have not used. Okay.
This part you are going to you will be getting your answer in the third session when we'll be having some hands-on training on this ANN and principal component analysis. These things we are having. Sir, we are having one hands-on session in the afternoon. So I think there
Okay.
they will be getting this answer. And regarding that Anfil sir, Professor Pratyahar sir, he has agreed to take 2 sessions, and he will
Okay.
be covering that Anfil's part. So means the point where you have left here, I think Pratyahar sir will be starting from there. So that will be
Okay.
very much
Fine.
helpful to them. Uh,
Okay.
Excuse me, sir.
thank you, sir. Yes.
Okay.
Sir, can you suggest how can we prepare our data set? Because this is the very main thing to implement any model
Yeah.
of
Yes.
machine
Yes.
learning.
The data set. You should have some idea on the variation of the data set. Now, suppose you will take a sample which is more biased or a very small sample, then the result will not be good. During the training, you have to select different types or suppose your data set is very large, so you must choose each and every corner of the data set. For example, in manufacturing, by changing the control variables, uh, I have some variation in the output. If I change the control variables in a small range, then the output will be generated in the small range. So it will not give the variation that I needed in the global level. What is the variation I intend to do? That I cannot get. So data set is really important when or it should consider the variation, particularly at the training phase. If you have trained with different type of different variation, then only the results can be or output can be good. So you should have some idea on the variation. Otherwise, it is really difficult to, or it will be the training will be localized. Uh, this is what is required. And preparation, the choosing of the data set, that is what the important. And preparation means you have to make a training data set and the testing data set. That preparation is not important, but sampling of the data, that is what is important. Okay.
Yeah, sir. That's why I'm asking. So, if we are having a huge data, so how can we sample the data? Is there is any technique to select the select the samples?
No, you see, people use there are different types of sampling methods. Okay, in statistics, there are a lot of sampling techniques are available. So use any sampling technique to choose the data or sampling the data. So some people use the random sampling, some people use the by sampling. But as the you see during the survey, if your variation of experts are more, then you will get a logical conclusion. If your survey set is very small and it is localized, you will not get the good conclusion. So in survey, people use a lot of techniques for finding out the or the preparing that sample. So in the statistics, a lot of tools are available how to prepare the sample. You use those tools.
And sir,
Okay.
I have one more question. This is my last question.
Yes,
If
please.
we are having one data set and we are having two analyzers, that means two analysts is working on a single data set, but they are using the different methods and get the different results. So how can we validate our result? So analyst one is right or analyst two is right? How can we validate our result?
You have one data set,
yeah,
and two analysis tools, two analysis tools, right?
Yeah, sir. We are having two analysis tools. So how can we validate our data?
Then data can be
no, sir. How can we
okay.
validate our result?
You calculate the error. Calculate the error.
Okay. That means we have to minimize our errors.
Error. So which one is giving the less error? That is more useful. So people normally use the root mean square error.
I got the point.
Oh, okay.
Yeah. Thank you, sir.
Any more question? Okay. Any more question?
Sir, one is asking momentum parameter and learning parameter. How to choose them?
There is no clear-cut guidelines for choosing these parameters because it varies from data set to data set. It depends on the complexity of the data set you are having. But the thing is that learning parameter should be low. That means it should be low. If it is very low, then the number of iterations will be more. And if it is very high, then in that case, your learning will be fast, but the generalization will be difficult. So that's why you choose a learning parameter reasonably depending on the number of data you are having in the data set and the type of number of outputs you are predicting. Depending on that, you choose, and you have to do several iterations or several experiments to find a point and go on changing this learning parameter as well as the momentum parameter. Momentum parameter will be higher than the learning parameter, but there is no rule or no formula existing so far to choose these values. Only through your experience and experimentation you can find out the values, with the value that will give you the convergence or minimum error that is the best for you. Okay.
Yes, sir. I think we should conclude now.
Okay, fine.
If you have any further queries, participant, you can mail it to us so that those can be addressed. Thank you, sir. Thank you once again.
Okay, fine. Okay, I am leaving now.
Yes, sir. Thank you, sir.